Hello everyone and good evening. So today we are going to do circles for ninth class. So let's join fast so we can start this. Okay. So in ninth class, circle is like I would say it's kind of lengthy one. Why? You will see lots of theorems in here. Lots of theorem you will see, and also like it's kind of confusing. I admit that it's kind of confusing. Give me a second. Like there are like are you going to study about 16 or 18 theorems in this chapter and many terms. That's why it's quite confusing chapter. So let's start. Okay, so let's start with terms related to circles. What are the terms related to circle? First, circle. What is circle? Circle is a collection of points, all the points which are equal distance from a fixed point, which are equal distance from a fixed point. Circle एक collection of infinitely many points, और उन सब के अंदर एक एक प्रॉपर्टी है कि उन सब का डिस्टेंस एक फिक्स पॉइंट से इक्वल है. फॉर एंड दैट फिक्स पॉइंट नोन एज अ सेंटर. Like if you stand at any point on this circle, let's say you are standing here, then the distance between center and you, let's say this is r, but now you are standing here on the circle. Again, distance between you and this center will be r. So this is what a circle. All these points are equal distance from this center. Okay, so this is circle. Now what is radius? Radius is the distance, that distance between you and the center. Like we made a circle and you are standing on a circumference or on the boundary of that circle, then the distance between you and that center is radius. The distance between you and this center, distance between this boundary and center is r, known as a radius. How many radius can you make here? I can make like this, this. So infinitely many radius are possible for a circle. Next, congruent of circle. See, you have studied about the triangle congruency. What is, if two triangles are congruent, what can you say? Sir, the area will be equal, corresponding sides will be equal, corresponding angles will be equal, corresponding parameter will be equal, all things will be equal. In the same way, circles can be also congruent. But to prove two triangles congruent, what you have to do? You can use SSS, SAS, ASA, but in circle you need only one thing, R. If the radius is equal, then both circle will be congruent. It means the area of this circle and this circle will be equal. The length of this boundary for both circle will be equal. Everything will be equal for them. Okay, everything means the overall property of this circle and overall property of this circle will be same. And what properties I am talking about? Like if you make a let's say this is 60-degree angle, then the area of this section, and if you make 60-degree angle here, then area of this section will be equal. Okay, that's it. Now next, we have chord of the circle. What is chord of the circle? Choose any 2 points on the boundary of circle and connect them. Choose any 2 points on the boundary of the circle and connect them. You will get a line. That line known as a chord. And because of that chord, can you see this circle is this chord is dividing this circle into 2 parts, not equal, 2 parts. Okay, now next, diameter. What is diameter? Diameter is the longest or the lengthiest chord, we can say the lengthiest chord possible inside a circle. एक सर्कल है, उसके अंदर आप कई सारी chords बना सकते हैं. For example, this is circle, this is chord, this is chord, this is chord. As you can see, I am going closer and closer to center. The length of this chord is increasing, but after the center, this will decrease. So what is diameter? Diameter is the longest chord or a chord of a circle which passes through center. Diameter is a chord which passes through center, which passes through center. And the diameter and radius has a amazing relation. That diameter is just the double of radius. Diameter is just a double of a radius. If a circle has diameter of 10, then radius is 5. If the radius of a circle is 20, then the diameter will be 40. Now next, circle has infinite number of diameter. Yes, I can make infinitely many lines which passes through this single point. Infinitely many lines are possible which passes through the center. Center is just a point. Okay. Any chord that is not passing through the center of a circle is shorter than its diameter. As I told you that this diameter is the longest one chord. So if another chord you are picking up, that chord must be less than the diameter. A diameter is the longest chord. Okay. Next, relationship between radius and diameter, we have already talked about it. The diameter is just double of a radius. Next, arc of the circle. You already have studied all these arc, section, sector, all these three things in your, I think, 8th class, right? So now an arc which is less than half of the circle is called minor arc. But what is arc? First, let's go for recall. Let's go for recall. This, can you see this part? If you take a boundary part of a circle, boundary part of the circle, not complete boundary but a part, okay, if the part is less than half of the circle means, let's say from here to here is half. If this part is less than, yes sir, it is less than, we call it minor arc. And if you take this arc, this is called as major arc. Minor arc, major arc, clear? Next, yeah, how to denote a arc? Like I have to denote this arc AQP, then we write in this form AQP. This is minor one in this picture, and as you can see APB, this is major arc. Now let's go for next, semicircle. What is semicircle? Half of the circle. Every diameter divide a circle into a equal parts. Every diameter divide this circle into equal 2 parts. So one part known as a semicircle, another part also semicircle, and combine them will make a circle. Any doubt till yet, anyone? Next, sector of the circle. What is sector? You have studied this, I think, in your 8th class. If not, see, if I make two radius, then I will get an arc. Then the area between them, area which is covered by two radius and one arc, two radius and one arc. This area known as a sector, and you can find this area using a formula. Just change your angle. If you know this angle, you can find this area. Let's go for next. Circumference of a circle. What is circumference of a circle? Total boundary length. Like if I will give you a rope and I will ask you, you have to make a circle with a diameter of 10 meter, then how much rope do you need to make that circle? That the length of that rope will be circumference. Circumference is what? The boundary of the circle, the length of the boundary of the circle. That's it. Now segment. What is segment? We have talked about the chord. What chord do? Chords, they divide the circle into 2 parts, not necessarily equal, but yeah, diameter divided into equal 2 parts. But let's talk about in general chord. Okay, the chord divide the circle into 2 parts, 1 part, 2 part. This part known as a section, and they also are minor and major. This part is minor. Why? Because this part is surrounded by chord and minor arc. That's why it's a minor part. It's a minor segment. Now what about this? It's a what? Major arc. And this chord. Then this area known as a major segment. Any doubt till yet, anyone? Point on a circle. Okay, see guys, if you have any point, it can be inside the circle, it can be outside the circle, it can be on the circle. But sir, how to find that? If I tell you there is a circle with a radius 5 and there is a point, the distance between that point and the center is 4. Sir, it's less than radius, then it must be lie inside the circle. This point must lie inside the circle. Now if I will give you, let's say, another point whose distance from the center is 10. Sir, this distance is greater than radius, so it must be outside. and if I will give you another point, the distance between the center and that point is 5, equal to radius, then that point lies on the circle. Any point lies outside, the distance between them greater than radius. Point lies inside, the distance between the center and that point less than the radius. Point lying on a circle, then distance between that point and the center will be equal to radius. That's it. Now next, see what this is nothing, we just have discussed this, that a point is less than the distance between point and the center is less than r inside the circle, equal to r on the circle, greater than r outside the circle. So outside point known as exterior point, inside point known as an interior point, and they are boundary points when equal to r. Okay. Now second, what is second? Like there is a circle in a space and I draw many lines. Some lines are passing through the circle. Those lines who passes through the circle and cut the circle on 2 points, they known as a second. But sir, if a line is passing through circle, it will always cut on 2 points. There can be only 2 cases. One line does not touch the circle at all. Another line cut the circle, go inside and come outside. ओके, लाइन सर्कल के अंदर जाती है और बाहर आती है तो ऑब्वियसली 2 बार कट करेगी, और एक है कि लाइन कभी टच नहीं करेगी. बट एक और केस होता है, लाइन सर्कल को सिर्फ एक जगह टच करेगी और ये स्पेशल काइंड ऑफ लाइन होती है. लेट मी टेल यू अबाउट दिस लाइन. दिस लाइन नोन एज अ टेंजेंट. This line known as a tangent. See this line. This line is passing through only one single point of this circle. One single point of this circle. If there is a line which touches the circle on a single point, such a kind of line known as a tangent. Known as a tangent. This tangent has many properties related to circle. We will study about them also. Concentric circle. Concentric circle. You have one center. Let's say you made a circle with a radius of 5. Okay, it would look like this. Then you increase the, you have seen your compass. Like currently my compass is like this, here, this. But if I increase this, I will get such a kind of circle. So what is the common between these two circles? They have same center. So if you have same center, then such a kind of circles known as a concentric. Sir, it can be only 2 circles? No, it can be infinitely many circles. We can call them a family of circle. What is the family? Sir, family is every member should have something common among them. So what is the common here? Common here is center. Every member of this family have same center. That's it. So we have studied all the terms related to circle. Let's do this. Name the circle. How to name the circle? Take center, make a circle, or you can just denote like this also. Okay. Now name a radius of the circle. See, I can see 5 radius, I think. KO, KQ, KP, KR, KN, KO. All these are radius. Name a chord of the circle. RP, NO. Now name a diameter of the circle. Diameter is a kind of chord which passes through the center. RP. That's it. Any doubt till yet, anyone? Okay. DF and PG are diameter. DF and PG, they are diameter. Okay. If DF is 10, find DA. If this value, complete value is 10, then what about this? Sir, 5. Because radius is just half of the diameter. If AG is 12, now new case, AG is 12. Okay. Then LA. AG is 12, then sir, this is also a radius, it will be also 12. For this case, there are actually, it's not one question, there are 2 questions. For first case, we have DF 10, then the radius will be 5. In next case, we have radius of 12, then this value will be 12 also. Next, These two, this question. The diameter of circle A, circle B, circle C are 10, 20 and 14. Find XB. We have to find this value. We have to find this value. See, in the question it is given that this circle, circle B, has the radius of 20. So this value must be 20. And then this circle A has the radius of 10. Now can you find the value of this? It will be nothing but 10. 20 minus 10. That's it. प्रिंस क्या है कि ये कैमरा एक जगह सेटअप में होता है, सो मैं ऐसे रूम नहीं दिखा सकता, बट फॉर योर इन्फॉर्मेशन सी at this point I have a screen where I can read your comments, and this complete room is a black, so we don't get any reflection and all, because black walls can absorb maximum amount of light. So all the walls are black, and here we have a screen. That's it. Okay, and just behind this this screen where I can read your comment, just behind it we have a computer which control all the like live class, like when I have to make it live, when I have to make it recorded and all. Okay, now angle subtended by the chords. Angle subtended by the chords. Let's say you have a circle. Okay, now this is your chord PQ. PQ, it's a chord. Okay, then if you choose any point on a circle, it can be here upside of this chord or downside of the chord, any point. Now if you connect these 2 points with this, you will get another 2 chords and you will get a angle. We call this angle subtended by the chord on the circle, on the circumference. But if you connect these 2 points with the center, what you will get? Sir, this is not a chord but a radius. Yeah, it's a radius, and this is also a radius. So you will get another circle. We call this circle angle subtended by chord on the center. Okay, you guys are clear with these terms? Equal chords of this circle subtend equal angles at the center. Okay, now let's say you have 2 chords AB and DC, and it is given to us that AB is equal to DC. AB is equal to DC. Then the angle subtended by these two chords on the center will be equal. It means this angle and this angle will be equal. But sir, why? Why? You can easily prove it. How? See, in the question it is given that this line and this line is equal. Now what about this line? Sir, this is radius. What about this line? This is radius. What about this line? Radius. This is what? Radius. Now using SSS, you can prove that these 2 triangles are congruent, and using the property of congruent triangle, you can prove this angle and this angle will be equal. And also one more thing, can you see this AOB is an isosceles triangle? Then this angle and this angle will be equal, and because of they are congruent triangles, we can say this and this will also equal. So these 4 angles will be equal and these 2 theta will be equal. So this is first theorem. All the theorems in this chapter, you will see that one theorem is just a converse of another. Like see, another theorem, if the angle subtended by the chords of a circle at the center are equal, then the chords will be equal. Now in this question, what is given to us? That this is angle theta, this is angle theta, then AB is equal to DC. In the previous one, it is given AB is equal to DC, then theta and theta equal. But now theta and theta are equal, it is given. Now you have to prove that AB is equal to DC using SAS. Why? Sir, this is R, this one is R, this is R, this one is R. Then OC and OD are equal to OB and OA. And it is given that theta and theta are equal. Then using SAS, you can prove that these 2 triangles are equal. That's why this line and this line must be equal. Next theorem, equal chord of congruent circles subtend equal angles. You have 2 congruent circles. Congruent circle means the radius are equal. Radius are equal. Okay. Now if it says that this line is R, this line is R, and this is DC. and it is given that AB and DC are equal, AB and CD are equal, you can say. This is what R, this is what R, but sir they are congruent circle na, that R and R are equal. Then by using S, we can prove that these two triangles are congruent, and they are congruent, then this angle and this angle must be equal. That's it. Now next, if chord of congruent circles subtend equal angles and their centers, then the chords are equal. Now just converse of it. At that point the chords was given to us equal. Here the angle is given equal. There you prove that angle is equal. Here you have to prove chords are equal. They are congruent circle. Then this value is R, this value is R, this value is R, this value is R. This angle and this angle is equal. Using SAS, we can prove that this triangle and this triangle are congruent. And congruent triangle, then corresponding lines should be equal. This line and this line will be equal. AB will be PQ. Two circles are congruent if they have the same radii. Prove that equal chord of congruent circles subtend equal angles. We just have proved it using SAS or SSS. We have proved both the theorem. Now let's talk about next, perpendiculum from the center on the chord. Okay, you know what, if you have a circle and there is a point center, this is center C, and we have a chord, let's say AB, then if you draw a perpendicular on this line AB na, then this perpendicular will meet at the midpoint of this line AB. It means AS will be equal to SB. Kab? Jab CS is perpendicular on AB, and they are conversely, like they are converse. Why? Why, sir? Why it's true? Like if you connect this C with A, this value will be what? Sir, R. This value will be what? Sir, R. Don't you believe that CAB, it's an isosceles triangle? Yes, sir, it's isosceles triangle. And if isosceles triangle from a point, let's say C, here you have the equal lines, and if you draw perpendicular on that third line which is not equal, what happened? That, sir, median and perpendicular work same. Like this is its perpendicular also, this is its median also. And what median do? Sir, it divide the opposite side into two equal parts. Okay, and in the case of isosceles, sir, that work also done by perpendicular. So that's why if this is perpendicular, then it will be equal part. If they are equal, this must be perpendicular. That's next theorems are these, like equal part, it must be perpendicular. If it is perpendicular, then they should divide into equal parts. Like in this question, what it said, the perpendicular from the center of the circle, it's on its chord, bisect the chord. It means AB should be equal to BC. Now next, okay, next is what? If you draw a line from center to on this line AC, and this part and this part are equal, then this must be perpendicular. Okay, so both things we have proved. Using isosceles triangle. There is one and only one circle passing through three known collinear points. Okay, see, if you give me any 3 point on this space, okay, if you give any 3 point in the space, I can give you a circle. But sir, can you give me only one circle? Yeah, I can give you only one circle. What does it mean? If you give me 1 point, if you give 1 point, I can make infinitely many circles like this, or this. So I can make infinitely many circles for single point. But what about 2 points? For 2 points also it's apply that if there are 2 points, you can make more than one circle. But if there are 3 points, you cannot make more than one circle. That only one circle will passes through those 3 points, and except that circle, there will be no circle which has this property that it's passing through all these 3 points. But what about, sir, 4? In case of 4, there can be only one circle or 0 circle. There will be 2 cases. For 3 point, there will always one circle. For 4, there is a case like these 4 points are at such a position that you can make a circle or not. So it depends. So for 4 points, 4 non-collinear points, there can be a circle passing through them or there cannot be, there may not. But for 3 points, there must be one circle which passes through all these 3 points. Two circles of radii 5 and 3 intersect at a point and the distance between them is 4. Find the common chord. Okay. There is one circle with a radius 5, another circle with a radius 3. This is 3 center, this is 5 centers, and the distance between them is 4. If you make a chord from the intersecting point to intersecting point, this will be what? 90 degree. Why? Because this line is from center to chord, and we have studied that if you make a line with center to chord, it will meet on center of this chord, and also from this to this it will meet on a center of this chord. Then this must be a single line. They both are meeting on a single point. If you connect this and connect this value is 5, this value is 3. Why? Because sir, they are what? The circle's radius. Now what about this part? This part you can take x, and this part 4 minus x. Okay, 4 minus x, and this part let's take h. Use Pythagorean theorem, eliminate h, find the value of x. Eliminate h, find the value of h, or you can eliminate x, find the value of h. If you get value of h, then this value and this value will be equal. Why? Chord, the perpendicular from center divide the chord into 2 equal parts. So you have to find just 2h. Okay, that's it. Equal chord of a circle or a congruent circle are equidistant from, yeah. See, there is a one circle. Okay, I make a chord, let's say 5 centimeter. Another chord here, 5 centimeter. This is also 5 centimeter. Then the distance between this chord and the center, this distance will be equal. And you can prove using the property of, see, this chord are equal, then this value and this value must be equal. And this is r. Okay, you have proved 2 sides. And this must be what? 90 degree. You have one angle equal. You can prove these 2 triangle congruent, and using the congruency, you can prove that this line and this line will be equal. Oh, sorry, this line. I have mistake one thing. I have done one mistake. This is your r. This is your r. Okay. So using the, there is also one more law for congruency, for especially for right angle triangle. Okay, that one radius hypotenuse, prove the hypotenuse and one line equal. Sir, one line is equal, hypotenuse is equal, and this is 90 degree, this is 90 degree. Then this must be equal. Okay, RHS, right angle, hypotenuse and side. Using that, chord equidistant from the center of the circle are equal in length. If this is equal, and this is what? Radius. This is what? Radius. Then this must be equal, and they are what? Half of this. Half of them is equal, then full of them also will be equal. You can, using again right angle triangle, hypotenuse and side, RHS, using RHS, you can prove this theorem also. Next we have angles subtended by the points. See, take 2 points on this circle and then choose any other point on the circle circle boundary. You can choose here, you can choose here, and connect them. You will get one angle here, and connect with the center, you will get one angle here. These 2 angles has a relation. Hello, these 2 circles, these 2 angles have a relation. What the relation is? The angle subtended by an arc of a circle at the center is twice the angle subtended by it at any point on the circle or at a point on its circumference. Okay, like let's say this angle is alpha, then this angle must be 2 alpha. Okay, if this angle is k, then this angle must be 2k. This angle is a, then this must be 2a. And this is special case when you have those 2 points such that if you connect these 2 points you get a diameter. In this case what happened, diameter is single line, then sir this must be what, 180, then this is 180, then this must be what, 90 degree. So whenever you have a circle, okay, and you have 2 points, let's say these 2 points, and they make a 90 degree angle at any point, like here or here, like this is 90, this is 90, or here, or this is 90, then these two, if you connect these 2 points, that must be a diameter. Okay. But sir, how to prove it? How to prove it? It is easy to prove. See, this is what, sir, R, this is what, R, this is what, R. Okay, let's take this angle is X. Sir, this is R, then this must be X. Let's take this is Y. Sir, this is R, this must be Y. Okay, find the value of this angle. X plus this angle should be 180, then this angle is 180 minus 2x. 180 minus 2x. What about this angle? Again, sir, triangle AOP, this angle and this angle and this angle must be equal to 180, then this angle must be 180 minus 2y. And this angle we have to find. Let's say this is alpha. Then sir, this angle plus alpha, this angle plus this angle plus alpha should be 360. From here you will find that alpha is equal to 2 into x plus y. And what is x plus y? This angle. As you can see, this angle is coming out to be what? Twice of this. Twice of this. That's it. That's how you can prove this. Next, angle in the same segment of a circle are equal. Okay. See, we have this P, we have Q. As I told you, you can choose any point. You can choose any point. But for this, you have for center there a fixed point. This angle will be fixed for sure. This will be alpha. If you choose any point on the boundary, like if you make this one also, then this angle, all of them will be alpha by 2. All of them will be alpha by 2. Alpha by 2. So all these angles will be equal. Okay. If you are using one single arc to make it these angles, then all the angles will be equal. Now next, if a line segment join 2 points subtended equal angles at 2 other points lying on the same side of the line segment, then these 4 points lie on a circle. Okay. Like I have this point, I have this point. Okay. I have this point, I have this point. I connect this point with these two. Let's say this angle is alpha. I connect these 2 points with this point. Let's say this is also alpha. Then these four points, let's say this point P, this is U, this is A, this is B. These 4 points will be a co-cyclic. Co-cyclic means, as I told you, that for 4 points, there is no surety that you can make always a circle passing through all the 4. No, there is no surety. But if you get this kind of condition, then there will be a surety that there will be a unique circle passing through all these 4 points. All these 4 points. That's it. That's what this theorem states. Now, cyclic correlator. What is cyclic correlator? If you have a circle and if you choose any 4 point on this circle, 4 point on this circle, then connect them with the chords, you will get a correlator. This correlator known as a cyclic correlator. So what is the property of this correlator? Like what is special in it? As I told you that if you have 4 points in space, there is no guarantee that you can make always a circle. For a 3 points, there is a guarantee, but there will be only unique circle which passes through these 3 points. But 4 points, there is no guarantee that you will get always a circle passing through all these 4 points. But if you see the coordinator, a cyclic coordinator, if I will give you a coordinator, let's say this is a coordinator, and if I will call you that this coordinator is a cyclic coordinator, then from there you can easily find that it means, sir, there should be a circle passing through the vertices of this coordinator. Vertices of this coordinator. There will be a circle, but it is not true for every coordinator. This is true for only cyclic coordinator. Now let's study the properties of cyclic coordinator. One property is opposite angles are, sum of the opposite angle is equal to 180. This and this. The sum of them will be equal to 180. Sir, why? You can prove easily. Connect this line to this line. Okay. And sir, is it passing through center? No, there is no guarantee. There is no guarantee that it is passing through center. So I should make center first. Give me a second. Let's say here we have center. Let's say here we have center. Connect this with this. Okay, this is a single line, this is a single line, this is R, this is R. Okay, let's say this angle is alpha. Then sir, this angle must be what? Alpha by 2. Okay, this angle X, let's say this is X, this is Y, this is Z, and this is W. Okay, if this circle is alpha, this circle is alpha by 2. Okay, then what can you say about this angle? What can you say about this angle? Sir, 360 minus alpha. Yeah, 360 minus alpha. Add all these angles. Add all these angles. It is a quadrilateral. CO. Let's say this center is O. COAB. This is a quadrilateral. Then sum of them should be 360. If you do that, now, if you do this and also find the value of W and Y, at the end you will find that X plus Y plus W plus R, this value is coming out to be 180. This value is coming out to be 180. This is W plus R is what? This angle. X plus Y is what? This angle. And from here you can prove it easily. Now anyone, any doubt? This is alpha. This is alpha by 2. And this is 180 minus alpha. Yeah, 360 minus alpha. This is 360 minus alpha. Let me explain you again. Let's say there is a center. Connect this center with the vertices, any two vertices. Let's say this angle is alpha. Then this must be alpha by 2. And this must be 360 minus alpha. This angle X. Let's say this is Y. This is W. This is Z. Now, what you have to do? Addition of these four angles, W plus X plus 360 minus alpha plus alpha by 2. This will be equal to, this will be equal to 360 because of sum of all the angles of a quadrilateral. Now take this angle. This angle will be what? Sir, half of this angle. Half of this angle is 180 minus alpha by 2. So this angle is 180 minus alpha by 2. Add this, you will get equal to 360. You get two equations. From these two equations, you can eliminate alpha. Eliminate alpha, you will get this theorem. Let's go for next. Cyclic quadrilateral. Okay, cyclic quadrilateral, there are some property. Cyclic parallelogram is a rectangle. Sir, why? Because parallelogram has this property that this angle and this angle should be equal. Let's say this is alpha, this is alpha. And if this is a cyclic, then sir, because of cyclic, we have property that alpha plus alpha should be equal to what? 180. From here you can find alpha must be 90. So a parallelogram whose angles are 90, it's a rectangle. Similarly for rhombus you can go, trapezium for you can go, cyclic rectangle is a rectangle. Yeah, rectangle is a rectangle, square is a square. Cycling quadrilateral, the sum of either pair of opposite angles of a cycle of a quadrilateral is equal to 180. We have already proved that this angle and this angle, sum of them should be equal to 180. This and this, sum of them should be 180. Next, the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Okay, how to prove it? Sir, let's say this is alpha, this is beta, and this is what? 180 minus beta because of linear pair. Sir, we know that alpha plus beta, it must be 180 because they are cyclic quadrilateral, opposite angle of a cyclic quadrilateral. Then alpha must be equal to what? 180 minus beta. What is the exterior angle? 180 minus beta. What is the value of alpha? 180 minus beta. So obviously this angle is equal to this angle. This angle will be equal to this angle. This angle will be equal to this angle, and this angle will be equal to this angle. Any doubt, anyone? Now next, if the sum of the pair of opposite angles of a quadrilateral is 180, the quadrilateral is cyclic. Easy, yaar. I have a quadrilateral. This angle and this angle. Okay. The sum of these two angles is 180. then it will be a coordinator, cyclic coordinator. Cyclic coordinator, what is the condition? That sir, sum of the opposite angle should be equal to 180. How did you prove that? Sir, we proved that using that angle subtending property, that angle subtended on center should be twice of the angle subtended on any point of a circumference. Okay, use that property to prove that this and this must be, sum of these two must be equal to what? 180. Then the reverse part should be true. Okay, the reverse part is also true. You can easily do it, like let's say take any point here and connect this such that this angle is twice of this and this angle is twice of this. Using this you can prove the property, or any other way. Yeah, that's, I think that's enough. It will work. Okay, give me a second, huh? And also one property we talk about, that both the angle are subtended equal, that equal property will not work. Okay, next, if there is a quadrilateral inscribed in a circle, then the product of the diagonals is equal to sum of the product of its pair of opposite side. Okay, what it says, let's say you have a quadrilateral. Okay, let's take AC into diagonals, multiplying the diagonals DB. Okay, it should be equal to sum of the product of the opposite sides. Okay, AB, what is the opposite side of AB? DC. Plus, let's take AD, what is opposite sides? BC. That's it. Okay, so this is the property. But sir, how to prove this property? See, to prove this property now, you need the knowledge of similarity of triangle. Similarities of a triangle is a part of 10th class. Okay, but I can give you one thing, that let's take a point on this K. Okay, and this point K must be such that if you connect this point with the C, then this angle and this angle must be equal. This angle and this angle must be equal. Using this you can prove this property if you know the similarity of triangle thing. Okay, it's a complete concept. You will study that in your 10th class. So any doubt till yet, anyone? Any doubt till yet, anyone? Okay. Let's talk about here. Do you believe this, that this angle and this angle will be equal? This angle and this angle will be equal. Why, sir? Because see, this angle is, how this angle is like building here. Sir, you have this chord, and as you know, if you have one chord and you make angle subtended by this chord on the circumference, the angle will be equal. No matter you make how many angles, like if you make this, you make this, they will be equal. Then this angle and this angle must be equal. In a similar way, you can say that this angle and this angle must be equal. So if this is x and this is y, then this must be what? Y, and this must be what? X. Now what about these two angles? This angle and this angle. They will be also equal. Why? Because they are subtending by this. So this angle and this angle must be equal. This is, let's say this is W, then this must be W. Okay, so that's how you can prove these angles equal. Which angles? This angle is equal to this angle. Now, using this color, this angle equal to this angle. Now, let's use green. This angle and this angle must be equal. Okay, we have two angles left. Yeah, these two angles. What color should be would be good on this blackboard? Let's take light blue. And this angle and this angle must be equal. How? Because these two blue angles are made because of the DC, the subtended by DC. White angles subtended by the CB. Yellow angles subtended by the AB. And green angles subtended by the AD. That's why they are equal. Okay. Okay. So any doubt till yet, anyone? Any doubt? Okay. Tangent to a circle. Now let's talk about tangent. The tangent makes a right angle with a radius. Okay, what is tangent? If you draw a line, such that it does not cut the circle but passes through circle and touching the circle on a single point, and you connect this point with a center, it will be make 90-degree angle here. This is what? Tangent. Okay, from a single point P outside of a circle, from here you can make maximum 2 tangent. Sir, minimum be 2. If a point lies outside of the circle, you can make 2 tangents, and these 2 tangents, length of these 2 tangent means P to A will be equal. Sir, how can we prove? Using RHS, right angle triangle, hypotenuse and one side. See, take triangle OPA, triangle OPB. This line and this line equal? Yes sir, both are R. Both are right angle triangle and both have same radius. Oh sorry, both have same diagonal. That's why both of them are what? Congruent. Then this line and this line must be equal. This angle and this angle must be equal. Okay. See, POB and POA both are equal. Also this angle and this angle will be equal. So it means this line PO bisect the angle. Which angle? Angle between these two tangent. This angle. This angle get bisect by this PO. The line that connect the exterior point to the center divide the angle between the tangent into 2 equal parts. That's it. Let's go for next. Okay, so we have covered every single topic of circles. So anyone has any doubt? If you have any doubt, please let me know.